blow my nose. So.
All right. So the concept of conservation of linear motion doesn't change. Okay, total momentum before still has to equal the total momentum after. We still have to have conservation. So we have in the x direction, the momentum before is equal to the momentum after, and in the y direction, the momentum before is equal to the momentum after. That part doesn't change. What does change is that we are going to add in one component, and that's trig. Okay? And we worked lots of this last year. Cos of theta is equal to, how do we find cos theta?
Oh, adjacent over hypotenuse.
The sine of theta, opposite over hypotenuse. And the tan of theta,
Okay, or opposite over adjacent.
and then obviously we're working with a triangle pattern here, so what's another component that we use when we're working with triangles?
Oh, Pythagoras?
Pythagoras theorem. Okay, those are all components that we're going to start using. And we're going to start using these components to find x direction independently and y direction independently. Before, and then x and y independently after. So you have a whole lot of numbers on your page. That's why being organized in your, when you're writing your steps down is really going to come into play.
Oh, I'm great at that.
Okay, so solving 2D direct collisions is the same as linear, but you have to find P of x and P of y for each object, and then P total and Py total after, and you create that new triangle. Okay, so same as when we were doing the boat crossing the river last year in physics, this is the same idea. Okay? A 4 kilogram object is traveling south at a velocity of 2.8 meters per second when it collides with a 6 kilogram object traveling east at a velocity of 3 meters per second. If these two objects stick together upon collision, at what velocity does the combined masses move? This is where drawing a picture is going to become really important. So object 1 is traveling south at a velocity of 2.8 meters per second when it collides with an object traveling east at a velocity of 3 meters per second. If these two objects stick together upon collision, what velocity does the combined masses move? So we have some information in here that we can add in. What pieces of information do we know?
Mass of the first object, which is 4 kilograms.
Okay, and what's another piece of information, Cameron?
The velocity of the first object.
Okay, another piece of information, Sophia? Another piece of information, Chris?
The velocity of the second one's 3 meters.
Okay, another piece of information, Reese. This one kind of have to think through. Right. Okay, we're not given that information, but we know that information. The next piece of information that we know without calculating is that we have these things to consider. We have P of x plus P of y before P of x prime and P of y prime. Okay? So P of x originally P of x would be this way, and P of y on number 2 would be this way. So for object 1, this would be 1 and 1 total. And we also have here right? We now have this added part in here because we have the momentum in an xy direction for cart 1, and we have a momentum in the x and y direction for cart 2. So these 4 components together are going to be equal to the total x and y after. I know it's lots, okay? So when we look at P of x for 1, let's look at cart 1. What's the momentum for P of x? It would be 0. And why would it be 0, Reese? Because there's no velocity in the horizontal direction. And what about in the y direction?
$11.2.
11.2. Oops, not per. But we missed something very critical in this. What did we miss? Remember I said this is going to trip you up. Direction. And how do we indicate direction without putting negative? So where are we going to put the negative, Chris?
That one?
On this one?
Yeah, would you? It's going down.
Because it's going down. Okay, our velocity here is down. So this is negative 2.8 meters per second. So always make sure you're paying attention to that, okay? Okay, cart 2. What is momentum in the x direction for cart 2? Okay, and what about the momentum in the y direction for cart 2? Why, Reese? Because there's no velocity in the horizontal direction. And so this part here right? The sum of the total before is equal to the sum of the total after. Total momentum, I should say. So Px total before is going to be equal to 0 plus 18, and the sum of Py total is going to be equal to negative 11.2 plus 0. Okay, that's our Px total and our Py total before. Okay. And so what we say here is that our px total before, our sum of px total before is equal to our sum of px total prime, and our sum of py total before is equal to sum of py prime. So that means that this is also equal to px prime total, and this is equal to py prime total. Do we follow this through? The momentum that we calculate before has to be equal to the momentum that's after. And all that we have after right now at this very moment is the mass, the combined mass. So let's draw a diagram for this one. X is 18 kilograms meters per second. Is it positive or negative? Positive. So it's going in this direction. The next one is negative 11.2. Is it going to go up or down?
Down.
Down. So remember we do tip to tail. So the resulting vector that the carts travel after they collide is going to be in this direction. And we can figure out P prime total by doing our Pythagoras. Thank you. And what do we get for an answer here? You guys agree with Jada?
What did you get?
You have 14. I got 21.2.
I got 24.2.
Let's try that one again.
I got 21.2 as well. These brackets are under negative.
What am I doing?
Well, you square a negative, it's going to be a positive.
It's gonna be positive anyways.
I got 21.2.
But
There, I got 21.2.
Oh,
All I did was take the negative out of
did
11.2.
you get it figured out, Cameron? Okay, so this is the angle that we're figuring out. So what are we going to do? Tan is what? Opposite over adjacent.
Would you take the negative? Yeah, you take the negative out and
You take the negative out.
it's direction.
What do you get, Jada?
32 degrees.
Okay. The original question asks us for at what velocity does the combined mass travel? So momentum equals mass times velocity. Velocity equals
2.12 meters per second.
Okay, can you put it into significant figures? We've got 4.0, 2.8, 6.0, 3.0.
2.1 meters.
And what do we call this angle? What direction do we write this as?
South of west.
Fifty-fifty chance of getting it right, Jaden.
No, oh, south of east. Let's see, there it is.
Okay, so your answer is 2.1 meters per second, 32 degrees south of east. So there's a lot. Do you see that there is the potential to create an error early on that goes all the way through your whole problem? What's the biggest error that would have been made? The negative sign. Okay. And right now, here, it doesn't really matter because 11.2 plus 0 is 11.2 and negative 11.2 is 0 is negative 11.2. We do our calculations, it doesn't matter. But if this had a value, it would change.
So, can we think? Actually, never mind.
No, go ahead.
No, never mind.
You're good?
Yeah.
Maybe?
No, I'm definitely good.
Okay. An object, 4 kilogram object is moving at an unknown velocity when it collides with a 6.1 kilogram stationary object. After the collision, the 6.1 kilogram object is traveling at a velocity of 2.8 meters per second, 32 degrees north of east, and the 4 kilogram object is traveling at a velocity of 1.54 meters per second, 41 degrees south of east. What was the velocity of the 4 kilogram object before the collision? So let's set this up. Okay, so the information before that we have, what does it look like? What am I going to put on before?
A 4 kilogram object traveling at an unknown velocity.
Okay, so we're going to call that V1 arbitrarily. Okay, and what else am I going to put in there?
It collides with a 6.1 kilogram stationary object.
Ooh, I like it.
Okay, after the collision, what do we write? What does the after look like? What does the after collision look like?
The 6.1 kilogram object is traveling at a velocity of 2.8 meters per second, 32 degrees north of east.
So north of east, so that's this way. So this is 6.1 kilograms. And you said 2.8 meters per second. And that this angle here is 32 degrees. Okay, what about, let's keep going, there's more information here. Sophia, what would be something else we'd have to fill in here?
The first object is traveling at 1.5 meters per second south of east
So south of east,
at 41 degrees.
41 degrees, and you said 1.5, and this is 4.0 kilograms. Okay, and it's asking us for what is the velocity of the 4 kilogram object before. So we've done all of our labeling that we can do right now before we have to get into any math. We've put in all the information that's here. There's no information that we have to extract out of it. So this is where we're going to start. We're actually going to start on the reverse side. So we have, I'm going to change my thickness. We're going to have P of x1 prime, P of y1 prime here. And here we have P of x2 prime, and here we have P of y2 prime. And remember, we need the sum of the momentum before is equal to the sum of the momentum after, or the P prime. So we need totals of x and totals of y on each side. So how do I figure that information out? What's my next step? What would I do? You guys actually have the base knowledge for this. What would be a step, Jaden? I'm given a hypotenuse and an angle.
You could like find your opposite or your adjacent. You can,
I could find my x and y values by using trig, right? So if I wanted to find P of y, 1 prime, what is that? Is that opposite or adjacent to the angle? Opposite. So opposite over hypotenuse is which sign? Or is sine. Okay? Px1, Px prime, is it adjacent or opposite of the angle? Adjacent. And so which trig calculation is that one? Adjacent over hypotenuse?
I keep on thinking so adjacent
Close.
over hypotenuse.
And when we look at over here, Px2 prime, right here, is it opposite or adjacent to the 32 degrees?
Jason.
So we solve that using cos. And Py2 prime is going to be opposite over hypotenuse, which is sine. So what did we get for any one of these four values? If you have one, let me know.
P of x1 is 1.13 meters up.
I wrote something down wrong here.
What? What are you serious? For what?
A 4 kilogram object is traveling at a velocity of 1.5.
Like the coach? That's what I got.
Oh, I put the wrong mass, so I'm gonna have to redo my calculation. Okay, say, Reese? Kilograms, meters per second. And anybody else have another piece of information?
I could give you the sign
Sign for which one?
for the one that you found the codes for.
Okay,
Got 0.9840
positive or negative?
Negative.
Negative, and why are you saying negative?
Because it's going south,
Exactly, good
which
job,
is
Jaden.
north.
Perfect. Okay, any other calculations done? Oh,
Just what?
this is velocity. And what are we trying to figure out?
Oh, momentum. Ah,
Now we know the velocity for every movement.
So the momentum is what's 4 times 1.5? Half of 4 is 2, 4 plus 2 is 6. So that's my error. Well, not my error, it's something to be aware of because clearly I can still make those errors. Okay, you have to figure out the momentum, not the velocities. Something to pay attention to because it's obviously an easy error to make. So over here, momentum equals, I'll give it to you, 17.08. So I'm just going to erase this part here because I want to take those answers out. So what do we get for new values? Sorry, now that you have to redo all your calculations. Highlight this so I don't make this error again.
Oh,
When you get a value, let me know what it is. I will fill it in.
It's a 30-minute lesson.
It is.
How do you do most of the time?
No. I will photocopy these so you can work on these 5 questions though. What do you get, Jaden? Give me one answer.
The sine of y of first object equals 3.53.
Okay. And it's negative because it's going downwards. Good job. Cameron, did you get another number?
Px 1 prime is 4.5.
Okay, Sophia, did you get a number? PX2 or PY2 prime?
9 for the sign, 32.
For the sign?
Yeah. 9.05, 102.0.
I like that.
Okay, and Chris, did you get PX2 prime?
Is it 14.247?
I got 14.484.
Yeah,
That's what you got?
I think yeah, I thought the 0.08 on Philly.
Alright, so all that's done is gotten us our individual values. Now we need PX total and we need PY total. So here we have X 4.528 plus 14.484. And here we have negative 3.936 and 9.05. Yes? No?
Yeah, no, I
Oh, okay.
wrote a number that was
Okay.
the number.
So PX total Y for X. I have 19.012 and here I have 5.114. So our new triangle looks like this. In the X, it's in the positive direction at 19.012, and 5.114 is positive, so it's going up. So the overall collision moved this way. Moved to the northeast. So we're looking for this angle here. Hello. Moment. So when we do the trig on this, what do we get for total momentum prime?
Well, I'm still doing the addition part.
I was generous and gave you the answer.
So we write it down.
Oh, so let's process it.
Wait, what do you want?
I want somebody to tell me the P total prime. So that's this value here. This is P total prime. That's what we're finding, the northeast vector.
19.67779.
Hey, Jaden, look at you go.
That's what I got as well.
Good job. Okay, so we have P prime before, and it is asking us for
Well,
the velocity of the 4 kilogram object before the collision.
so we have 0 y velocity, or yeah,
Yes,
and we don't know the x.
right. But now that we have the total velocity, what?
You just-
Yeah, it should be kilograms for this.
Oh, I forgot the kilograms. I will write it after. Okay. What about our angle? Our theta is going to be opposite over adjacent. And what do we get? I know, math in the morning is so hard.
You don't even know.
Oh, in
Jaden, I gotta make sure that my brain's firing before I even present it. And clearly we've seen one fail of that already, so I get math is hard.
15?
Oh,
You get how many degrees?
15 degrees?
15 degrees. And we know that it's north of east. Okay, that's what the collision after ends up being.
nice.
Nice. Alright, 19.668. You do divide that by 4. You just flipping stole my thunder.
What? You?
Divide it by 4.
By what?
This momentum before, because the other one had no velocity, so the only other velocity that you're calculating is going to be the same as before. So, am I right in that was your logic thinking, Reese? Or you just took a guess to divide it by 4?
A little bit of both.
Okay. So what we found was P total prime after is equal to 19.688 with decimals, kilograms, meters per second, 15 degrees north of east. The question is actually asking us for V1.
Yeah.
Okay? The reasoning that Reese is saying, can't we just do, 'cause we
Oh,
know
I understand.
that velocity is going to be momentum over mass, so we're just going to go 19.688 divided by 4.
Because the other one doesn't work because there's no velocity.
Because
so it
there's
cancels
no
out.
velocity, and because it's conservation of the velocity before has to be equal to the velocity after.
What if you're in a vacuum?
We are. This is us in a vacuum because we have no
What
other,
if you're in
remember,
space?
isolated systems, there's nothing else, there's no friction, there's no nothing.
What about
Life is
space?
great. Okay? And the vacuum joke only works for Mac.
Okay.
Okay?
Yes, ma'am.
This is why this one works from P prime. Thumbs up, sideways, down,
It's not that hard.
thumbs up. Perfect.
It's very tedious.
There is a lot of writing, and I'm going to show you another method that's not any less
Tomorrow.
tomorrow.
Aye.
And give you some questions to work on
Monday, I mean.
tomorrow. No, tomorrow. Come tomorrow. I'll be here tomorrow.
Tomorrow's Saturday.
Yeah, because I have to drop Riley off so he can get on the bus to go to Peace River.
I am A-okay.
Yeah.
Actually, do you guys actually want to do that? Yeah.
What? Come to class tomorrow?
Actually, it would kind of be nice to get it done.